Hey guys, so today we're going to be working on combining like terms. So the first thing that I'd like you to do, let's go ahead and let's get our vocab copy down, and I want you guys to become familiar with it. So you're probably going to need to pause this video so that you can get that done. All right, so now that we've gotten all of our vocabulary written down, let's go ahead and let's kind of delve into what this actually means, and let's really start to apply it. Okay, so first things first, when we are looking at an expression is a problem with numbers, operations, and variables. So these are examples of expressions. We have numbers, operations, and variables, okay? So this would be considered an expression. So let's go ahead and let's kind of start defining what these parts of the expression are. So a variable. All right, guys, so we've been talking about this a good bit over the past few weeks. A variable is a letter that takes place of an unknown number. So that would be any of these. We do not know what this number is, so it's taking place of an unknown number. So our variables in this expression would be M and R. A constant is just a number and it never changes. So a number is a number is a number. Okay, so our constant in this is going to be our 2. He is never going to change. 2 is 2 is 2. And then coefficient is a number that is multiplied by a variable. So we've already talked about the variables, so that number in front of the variable, that's our coefficient. So we have a 12, an 18, a 3. And then guys, there's actually a number in front of this r. It's 1, which represents 1r squared. We only have one of them. So we'd have 12, 18, 3, and 1, because we only have one of the r squareds. Okay? All right, so looking at number 2, we can see again, this is an expression because it has numbers, operations, and variables in it. So the variables in this problem, we have C is an unknown number, C is an unknown number, R is an unknown number, and C again. So our variables are C and R. Remember that a constant is a number that never changes. It is what it is. It's the same thing. So that would actually be our 8 squared, because no matter what, 8 squared is always going to equal 64. It's not ever going to be anything else. 8 squared is 8 squared is 8 squared. So that's going to be our constant. Our coefficients are the numbers that are being multiplied by the variable. So we're going to find our variables, and they're those numbers right next door. Okay. So I have a 6, a 9, and an 8. We already have 6 written. And then let's go back to these two. So now let's talk about number of terms. Okay, so number of terms are the parts of an expression separated by a plus or minus. So we're going to look at the number of terms. So for this one being separated, I have 1, 2, 3, 4, 5. Everything that's in between the plus or minus. So I have 5 terms here. And in this problem, I have 1, 2, 3, 4, 5. So I also have 5. Anything that's being separated by the plus or minuses. All right, so now let's talk about a couple other terms. So we've talked about a variable, constant, coefficient, an expression, and a number of terms. Now let's talk about like terms. So like terms have the same variable, also raised to the same power. They have to be the exact same. Constant numbers, those are always the same. All right, so coming down here, let's just kind of go ahead and we're going to kind of start with the basics. So we've got 1, 2, 3 strawberries. I'm just going to put 3S. And I have 1, 2, 3, 4, 5 plus 6 bananas. And I have 4 apples, okay? So when doing this, can I combine my strawberries and my bananas? Nope, that would be a strawbana. I couldn't combine my bananas and apples because those are 2 different types of fruit. So I have an A's and the B's. So those are 2 different types of things. So we're going to keep that in mind as we kind of come over and we're going to start looking at it in a non-fruit form. And I may use fruit just to kind of help you guys get a grasp on what the variables are kind of looking like. So for number 5, let me go ahead and let's zoom in just a little. There we go. Okay, so for number 5, you can see it's 2A plus 8A. Okay, well, we could combine some of these. we have A's. Neither one have variables. They look the exact same. I have A's. Okay, so how many A's do I have? I have 2 and I have 8, so that would be 10 A's, like 10 apples. So these are the same, right? I can combine those. So it would be like 10 apples. Okay? And I do apologize, guys. I forgot to go down to numbers 3 and 4, which might make more sense, and then we'll come back to 5. Sorry. Okay, so starting back over again. Okay, so for number 3, we have a 4C, we have a 4D, we have a 7C squared, we have a C, and we have a 9. All right, so let's just kind of discuss which ones would be very similar, okay? So I have 4 cookies, all right? So I'm going to circle in pink my 4 cookies. Okay, do I have any more cookies? I have a C right here for cookies. And then I have a cookie squared. Is he the same thing as just plain cookies? No, he's not, okay? So I could only combine my 4 and my C. So that means I have a total of 5C, okay? I don't have any more like terms. I don't have any more D's. I don't have any more C squares or 9s, okay? And then I have 8. I have a 7y to the 3rd power, 7y cubed. I have 7y squared, 8x, 2y cubed, and I have 23. Okay, so do I have anything that's similar? I see that I have a y cubed here and a y cubed here. I cannot include my 7y squared because he's different. He doesn't look exactly like my y cubed. All right, now let's go ahead, let's come back up. Okay, so now let's combine what we have. So going back to number 5, I have 2a and I have 8a. Both a's are the exact same. Neither one have variables. They look identical. So I'm going to circle my 2a and I'm going to circle my 8a. I'm going to circle the sign in front of my 8a as well. So I have 2a plus 8a, which gives me a total of 10a. All right, number 6. So I have 5a plus b minus 3a. So let's put that in terms of like apples and bananas. I have 5 apples plus a banana minus 3 apples. So let's discuss what we can combine, what's similar. My apples can be combined. I can put my apples together. And remember, you always want to circle the sign that is in front of your term. Okay, so I have 5a, and this is telling me to subtract my 3a. So how many total apples do I have? I have 2 apples. I can't combine my b with anything, so we're going to leave him. So I have 2 apples and 1 plus 1 banana. Okay. All right, so for number 7, I have 16 muffins plus 16 minus 5 muffins minus 4 squared. So let's kind of talk about what we can combine. So I can put my muffins with my other muffins, and guys, remember to circle the sign in front of your term. So my total muffins, I have 16 muffins, and I'm going to take away my 5 muffins, so I'm going to have 11 muffins, okay? And then I'm going to do this in different colors so that you guys can see. If you don't have different colors, you can do different shapes to help you determine what's what. So then I have my constants, okay? Because remember, guys, 4 squared is a constant because 4 times 4 is always going to equal 16, right? So 4 squared is always going to be the same. It's never going to change. So I have 4 squared and I have 16. So I have 16, but then I'm going to take away 16 because I have my subtraction sign here. So I have 16, take away 16. So that's just 0. So you could do plus 0. But guys, do we ever really need to include a plus 0 in a problem? No. So we're just going to leave him as 11m. Okay. So I have 11 muffins. I didn't have anything else. All right. So number 8. Let's get this zoomed in just a little bit more. All right. Number 8. We have 6 bananas plus 5 apples minus 4 bananas plus 3 apples. Okay. So I have 6 bananas, and I'm going to combine that with my taking away of 4 bananas. So 6 bananas take away 4 bananas is going to give me 2 bananas. And then I have plus 5 apples. And then I have 3 apples. So that's going to give me a total of 8 apples. And I can't combine that any bit farther because we can't smush together bananas and apples. All right, number 9's a little bit bigger. And like I said, I still feel like I need to zoom in a little more. Okay, that's better. All right, so I have 8k squared plus 4k minus 3k squared plus 3 squared minus k plus 5. My goodness, guys, that's huge. All right, so let's think of these. We can think of k's as kangaroos. So we have the squared kangaroos and the regular kangaroos. Are these the same? Nope, they're two different. So I can do my squared first. So I have 8k squared, and I'm going to take away 3k squared. I cannot include this 3 squared because I don't have a k here. There's not a k squared. It has to be the exact same. So 8k squared minus 3k squared is going to give me 5k squared. Okay. Now let's look at just my plain k's. I have a plain kangaroo, and I'm going to take away a plain kangaroo. So I'm going to have plus 3 kangaroos. And then remember that my like terms constants are always like terms. So I have my plus 5. And then guys, remember 3 squared is always going to give me 9. So I have 9 plus 5, which is going to give me plus 14. Okay? And then one final problem, and this one's going to be a little bit of a tricky one, but it's going to be okay. All right, so we're going to write and simplify an expression for the perimeter of a figure. So guys, if we have a perimeter of something, that means we're going to be adding up all the sides, okay? Now we know a rectangle here. If this side equals A, that means this side equals A. And if this side equals 3b plus 5, this side is also going to equal 3b plus 5. Now, it has told us that we need to add up all of our sides. So we're going to add them all up. So I'm going to have my A plus 3b plus 5 plus my A side plus 3b plus 5. Okay, so let's go ahead and let's see what we can combine here. So let's combine my A's. I have an A here plus an A here. So that's going to give me 2A. And then I have my 3B and another 3B, and I'm going to be adding that. So 3B plus 3B is plus 6B. And lastly, I have my plus 5 and my plus 5, so that would give me a plus 10.